Do you know consistent hashing acts as the baseline for many of the NoSQL databases such as Cassandra?
No.
A few minutes later.
Hi, welcome to Design Strong. In this video today, we will try to learn about consistent hashing, which is an important topic for distributed systems. Before we start discussing about consistent hashing, we will first try to understand what is hashing. So hashing is basically like a function. Consider this as a black box wherein you're providing an input and in return it's returning an output which is dependent on the input and is always in the integer form. So for example, if let's say I'm inputting into my system ABC, then after completing or calculating the hash, it returns me an integer value, let's say 123. Let's try to understand hashing with the help of an example. Consider like this. I have a function which I'm calling it as hash. If the input was design, it does some calculations and calculate 3343 as the hash. Similarly, if the input was system, then the hash calculated is 1847. System design, then the hash calculated is 4599. So basically hash is more like a function which gives me an integer value for the input that I'm providing. This is just an example. There can be different formats of hash which may or may not be providing the output in the same integer format. In fact, there are some hashes which also calculates UUID as well. So this is just an example for simplicity. The whole idea about like calculating these hashes is to store this data in such a data structure that it can be retrieved back very fast, or let's say in O of 1. So what we have done is we have considered in our example that there are buckets in which we are going to divide the data. This is how it works in most hashed data structures in any language. So what we have done here is for 3343, we are calculating the hash mod bucket count just to see which is the bucket in which this data should be stored. So 3343, what we are doing is 3343 mod total number of bucket, which is 10. So it becomes 3343 goes into bucket 3, 1847 goes into bucket 7, 4599 will go into bucket 9. Fair and simple until now. So if I have to look at the bucket structure at this point of time, 0 until 9, and based on the hash that I calculated, design went here, system went here, and system design went here. Now these values in the brackets is only for your quick reference, because these in general are not stored. It's just that on the bucket we will have the data. Now with this, our hashing based bucketized solution for storing data was working fine. But there is a problem. Now let's see where the problem is. Coming back to the hash function, what we are seeing here is for every input it is providing a specific or a unique output. What if for multiple inputs it provides us with same output? Possible, right? Because let's say if our hash was designed to return only 4 characters, then it is quite possible that more than 2 strings we can have the same output. So what I have done is I have considered same example here. So design, system design, these were the 3 which you already have, and let's say if I included one more input, test design, and my hash function returns 1847 for test design as well. This is where we see that 1847 occurs twice. This is what we call it as hash collision. So hash collision, for your reference, is nothing but in case if for multiple inputs we are getting same hash, then we call it as hash collision. Now how to fix this hash collision? Do you think really it is a problem? Looking at it from this point of time, yes, it looks like it is a problem, but let's say if we have to fix this problem, the solution is very simple. Here we are storing the values directly into the buckets, right? In order to fix for hash collision, what we do is we store them into a list. Both test design and system comes into the same hash. So both system and test design comes into the same bucket because the hash calculated is same, and it is connected via doubly linked list and can be retrieved easily. So this problem of hash collision gets resolved here. But the real problem comes when, let's say, when we are working in a distributed environment. If I was getting 100 traffic, I have 10 buckets. What if the traffic increases or goes down? Let's say in that case, in order to optimize my solution, in order to optimize my infra for this problem, what I will do is reduce or increase the bucket count based on the benchmarking of traffic. So let's say if I have to consider an example wherein count of bucket has reduced to 9. So what happens to the hashing? What we will do is we will do a hash mod bucket by 9. So the updated hash becomes 4, 2 and 0. Earlier these were 3, 7 and 9. So you see what is the problem here? Entire data, almost entire data needs to be moved across buckets, which is something which we don't want, because let's say if these buckets have data in order of GBs, then this is not the optimal solution that we have. Now, in order to solve this, or what we are trying to achieve here is we need to minimize the movement of data which is required in case if there is a change in bucket count. This is where consistent hashing comes into picture. In order to understand consistent hashing, let's take it again with an example. So in the same example, if let's say for buckets, instead of having a number, what if I have a range? So ranges, what I have defined here is something like first bucket will have triple, like 0 to 999, then 1000 to 1999, then 2000 to 2999, so on and so forth. So every bucket has the same size, and the values are design, system and system design in the bucket 3, 7 and 9. Consider consistent hashing also as a hash ring, because let's say if there is a value which is more than 999, then it will go again into the same bucket and then this ring will continue. So 0, 1, 2, 3, 4, 5, 9, and then the same continues again, because these were the mods, right, that we calculated. Now in the same example, let's consider a situation that a bucket is removed. So let's say this bucket 7000 until 7999 is removed. Now what happens is the data that we stored earlier was on the basis of range. So let's say when design was to be stored, the value was 3343. We just saw which bucket is there in which this range qualifies. So if one bucket was removed, then what we do is just change the size of the next coming bucket so that it is able to grasp all the data which was there for the previous bucket as well. In this solution, the movement of data between two buckets is minimized, because whatever was the data that was there in 7000 until 7999 bucket comes into the next bucket. This can have some challenges in form of having more data into this bucket, but these are some problems which can be solved using different strategies. So for now, let's focus on how does consistent hashing work. So consistent hashing basically works like a ring in which, let's say, instead of having a bucket number, we provide a range to the buckets, and based on the ranges, we store the values into the same ranges. So in case if you found it helpful, do not forget to hit the subscribe button and also share this video with your friend, because this can be helpful for others as well. Hope you like it. Stay subscribed and say design strong.